Welcome to Maths for You channel. Past question on momentum mechanics. Two particles A and B of masses 2m and m respectively, moving on a smooth horizontal table along the same straight line towards each other with the same speed of u, collide directly. Just after collision, the particle A comes to rest. Show that the coefficient of restitution is half and that the magnitude of impulse exerted on B due to collision is 2 mu. So we need to prove that the coefficient of restitution is half and the impulse is 2 um. Okay, I'll put a little sketch to the picture will give us more explanation, more visibility. So particle A, B, particle A is 2m, the mass is 2m. Particle B is mass m, but they are traveling on a smooth horizon. That means there is no friction. That's what they said, smooth. So it's an extra information for us to not to think about the friction. So there's no friction, so it will freely move. So the velocity or speed, velocity, I would say velocity is a vector here. So the velocity of A is direction. I just put it sort of left to right direction, u, and the other one is the opposite way, moving towards. They are traveling towards each other. So the particle B is traveling left, so right to left with the velocity u. So they traveling on opposite direction towards each other, and then they're going to collide. After collision, says after the collision, the mass A come to rest. So yeah, mass A as 2m. The velocity, after collision velocity, I just put v here. That is equal 0, and again I keep the direction left to right. That's how I'm going to do it. And m, again, they didn't say anything about m, so that we just take it. There must be some velocity. Again, we take it left to right velocity vb, which we don't know. We need to find out. What we know, there are two particles and travel in the opposite direction towards each other and collide. We know by the law of conservation, the initial momentum equal final momentum. So the initial momentum for A and B is first A, and the direction I just put a little arrow left to right. So A's momentum prior to collision is 2m mass time velocity, mass time u, so 2mu. And the velocity, momentum of B, mass time velocity, I put minus u because of the direction we take from left to right. Therefore, that because it's vector, momentum is a vector, so the direction is important. So m times minus u. So the other is u on the right to left. So left to right is minus u. So mu. This is the initial momentum. But we know that the law says the initial momentum equal the final momentum, or final momentum in just after collision, or immediately after collision. 2m times 0 because of the A come to rest. So the velocity is 0, so we know 2m times 0 plus m times vb, which we don't know. We don't know the speed of the speed or direction. We just took it, the direction we took, 0. Sorry, vb. So left hand side 2mu minus mu, the right hand side 2m times 0, that's 0, so mvb. From that, vb is u. Just mm cancel out, vb equal u. And of course the direction As the answer is positive, so the direction left to right. So it's traveling on that direction. And the second one is a question we've been asked. Show that the coefficient of restitution is half. So the coefficient of restitution, I take it at E. What that is, velocity separation after the collision, velocity separation before the collision. So there is a relative velocity. So we are taking left to right again the direction. The velocity separation after the collision, velocity separation before the collision. So velocity separation after the collision is VB minus VA. So we just put it B first, BB minus VA. And then again, U, that is for 2m in the direction of left to right. And the velocity of B, particle B, in the direction of left to right will be minus u. So VB is u, VA is 0 because of the A came to rest after the collision. So the velocity is 0. And the denominator, u minus minus plus the 2u. The 2u you cancel out. You got 1 on the top. The denominator is 2, so half. So this coefficient of restitution is half. That one of the proof we've been asked to prove, that we have done. And then they said the impulse exerted on B. So just B, we need to consider. So impulse on B is what the impulse means, a change of momentum. So it's a change of momentum is after the collision minus before the collision. So after the collision of B, m is the mass, so change of momentum. So after the collision, the momentum on B is momentum of B is m times BB minus m times the direction is the opposite, left to right, right to left. So we are doing right to left. This is a vector. So minus m times minus u. So this is VB. We have already found VB equal u. So if you could use that or substitute that, so mu plus mu is 2mu. That is what we have been again also, that the impulse exerted on B due to collision is 2mu, which we have. So the impulse is the change of momentum before and after and before collision. Thank you. Please subscribe the channel and share the contents with your fellow students and friends. Thank you.